The other weapon that we have in our internal uh, immune system is inflammation. And I want you to think of inflammation as kind of the battlefield where all this happens, where the fight is for where these antigens have kind of invaded. So we've all experienced inflammation before. After a cut, you have some redness, swelling, heat, and pain. This is also known as the inflammatory response. What is causing this response is what we want to know is what is causing this response and how does this affect our bodies when it goes wrong. So again, this will be kind of the internal battlefield. So we'll take, for example, again, that we have our foot and we are stepping on a nail. And this top layer here will be our skin. So we have a layer of skin cells, and just below that are some mast cells. These, again, which are a type of white blood cell and phagocyte. And there are also some other phagocytes that kind of sit around in your interstitial fluid between your skin and your blood vessels, such as dendritic cells. And basically, they just kind of wait around until something breaks through our castle wall, our external innate system. And below our endothelial cells are the capillaries. And in the capillaries are red blood cells and white blood cells like neutrophils. So we'll say an intruder comes in. Our nail has gone through our skin, and all of a sudden now we have some bacteria floating around in our interstitial space. We've broken through our castle wall and broken through our first line of defense. So the bacteria is floating around the interstitial fluid, damaging all the healthy skin cells. So it's going to come over here and it's going to attach and get in here. And what it's trying to do is basically use our healthy cells rent-free to help multiply itself. The skin cells will start to release some chemical messages and signal for help called chemokines, not to be confused with cytokines. So chemokines. So these cells are going to start releasing these chemokines saying, help me, help me, help me, I'm getting destroyed. And this is not good. The mast cells will become activated from the damage of the cut from the chemokines or the chemical trails from the bacteria. So they could have been damaged by the tissue from this nail, or they could be activated from chemical messengers that are being released by the bacteria. But either way, our mast cells are going to say, hey, something's wrong. Someone's in here that's not supposed to be here. So what the mast cells are going to do is they're going to release inflammation substances, or what we call degranulate. So our mast cells are going to degranulate, and what they're going to degranulate is histamine. There's a few other things too, but the big one that we're going to concentrate on is histamine. Other leukocytes or white blood cells release histamine and or other chemical mediators. And other type stuff, co-stimulating molecules like cytokines, interleukins, chemokines. Basically, they start releasing all these pro-inflammatory substances to get cells, to call cells to the area, call to action, to get the battlefield prepped for war and start inflammation. So these pro-inflammatory mediators go to the endothelial cells of the capillaries. So they're going to come down here, all these little chemokines, cytokines, interleukins, things like that. They're going to come down here to the endothelial cells of the capillaries and tell them to separate and vasodilate. Okay? So all of a sudden our nice tight capillary is going to start to move outward. Is going to start to separate and swell. So we're going to start moving outward like so. These will go away, and we'll start getting these cells to separate. Okay. This will cause a swelling, and then our neutrophils and the white blood cells that are in here, these little guys, they're attracted to these chemicals that were released, and they'll move out of the capillary into the interstitial space. So if you think about it, we have all of these white blood cell soldiers inside our capillaries, inside of our blood, and we need to get them into this interstitial space because this is where the fight's happening. This is where our bacteria are, and this is where they're destroying our cells. So these chemokines will come in and tell our blood vessels to become big, separate, leaky, so that these big fat white blood cells, neutrophils, can now come out and join the fight. So now they can be out here and getting ready for battle. And again, these are part of our non-specific innate immune system. So they are just there to hopefully kill the bacteria, kill the antigen without any kind of memory or anything like that. So as the neutrophils start devouring the pathogens, these neutrophils will die, and they kind of gather up, and they'll end up becoming pus. So next time you see pus, you'll know it's dead neutrophils. We'll also get an increase in blood flow. So we'll get an increase in blood flow here to this area. And to get more neutrophils and other white blood cells to our battlefield. And this will also cause not only more blood flow, but an increase in heat. Okay, so that's why your cut starts to get warm. And this heat will help also increase the metabolic rate, so our tissues that are being damaged can hopefully be repaired faster. So at this point, if we kind of make a little column over here, we're going to have our capillaries have become bigger and leaky, so we have swelling. We have an increase in blood flow, which is going to cause an increase in heat, and that's also going to help with repairing any damaged cells. As our neutrophils continue on the battle, they'll die, which is going to give us some pus. And we'll also start, because of that increase in blood flow, we're going to get a redness in the area. Right? Pretty common stuff you'll see when we have that kind of infected healing cut. Now, the last thing that it can do, our innate system can do to help fight off these things quickly, because that's the goal. It wants to fight this quickly and keep it out of our lymph nodes. It's going to do is release what's called a pyrogen. Which is a chemical. Basically, you can think of it as a last resort hand grenade that's going to activate the hypothalamus and start a fever. So we're going to have the swelling and heat and redness from the capillaries, pus from our dying neutrophils, and if we're starting to lose the battle, our leukocytes can release pyrogen, and we'll get a fever to hopefully kind of scorch the earth of our enemy. And that is the inflammation. So from there, you could say that um, we have our innate process going on. Once we get some of these phagocytes that become antigen presenting cells, they'll go to the lymph node and recruit more help, which will take time, but they'll recruit more help from those B cells and those T cells for um, cell infected cell control and antibody production. And then we'll also end up leaving these memory cells around in our B cells and T cells in case we step on a nail again and get infected by this bacteria.